In this video, I'm going to review this little pocket oscilloscope. Now, the name of this, or the brand name, is FNISR, and then let me look at the model number quick, DSO152. And so I'm going to go through all the features and what I like about it, what I don't like about it. Now, one of the things I like about this is that it has a built-in lithium battery, and it's a 1000 milliamp hour battery, and so that makes it rechargeable, and it can recharge with a USB-C, which is standard, and so you don't have to buy some crazy USB port that they don't use anymore. It's up to modern standards. Now, they have a built-in 1 kilohertz calibration square wave, and I'm going to show you that in just a few minutes. And there is an auto feature that I really like, and I'm going to show you that too. And then if you are on a Windows machine, you can upgrade the firmware through that USB cable. And I am on a Mac, so I'm not going to be able to show that, so I'll be stuck with the firmware that they have. Now, the manufacturer mentions here that it has full trigger, auto, normal, and single, and I can't see any difference between auto and normal. That works. And then the single just takes a freeze frame of the current voltage. It's got a 2.8-inch display, and the resolution is 320 by 240. Now, that 10x switch on the side allows this to measure it up to 800 VPP. I always keep it at 1, but out of the box, it can accept voltages up to 400 volts. And I have tested it up to 120 volt AC. I have not tried it on the 240 side, so maybe I'll do that on a follow-up video and take a look at that. Now, let's start first with the probe. The probe plugs in right here at the top, and they have a standard BNC that they provide, and then they have this adapter right here. And the adapter goes down to this mini one. I don't know what the specification is, but this is, I guess it works okay, but I've seen that it kind of wiggles a little bit and the signal comes in and out. So I'm not real happy with this adapter. And I wish they would have simply put a bigger one in and put the standard BNC in. But I guess for 36 bucks, you get what you get. And so it does work, and I've been using it for a couple weeks, but I think it could be a little bit better. Now, right here on the side, this little screw right here is how you adjust the signal. So on the reference signal, if it's like ramping up a little bit like this, you go in there with the tool that's provided, and then you can turn that and adjust the square wave so that it's perfect. Now, I tried it with a Phillips screwdriver, and I don't have the tool that came with it today, and it didn't work. So I'll do a follow-up video and show the tool that comes with it and show you how to do that. But anyway, this is sort of a standard oscilloscope probe that it comes with. There's a little, the clippy thing there, and then it comes with the ground, and it works just fine. So I just wish they had put a better connection into the device. Now, as you can see, it's got a little stand there if you want to do that. And like I said, it's got the built-in battery. And I think that you can take the battery out, but I haven't really tried that. All right, now like all oscilloscopes, there is a reference signal right here. And then this is a square wave, and you can use this for testing purposes to make sure you have it set up right. All right, you can see we've got our square wave. Now, if it doesn't come out right, there are a couple things we can do. First, you can press the auto function and a short press there, and then listen. You can hear the relays clicking. And then it has found a solution. Like most oscilloscopes, you can change how the range and the period and whatnot. So if we go over here, this button right here toggles between the different settings, and you can see them turning blue. All right, so like if we're on 100 millivolt and we want to reduce or increase that scale, there's 50 millivolts, 100, 200, and whatnot. And then we can change the scale. Now, when it got into this and it won't display it correctly, that we may not be able to solve that, because so there we were able to sort of do it, but I haven't found a way to adjust the trigger like on a benchtop oscilloscope where you can adjust it so that it quits wandering. And so if it gets out of whack, then I think we were at 100 millivolts, I believe is what we were at. All right, and then the period, I think that was, okay, I think it was 500 microseconds. So that's how the auto function had it originally. And then you can always put it back, but the auto function is pretty handy. Now here's a sample code on Adafruit, and basically this is a pulse width modulation output pin. So here on my trinket, on pin 0, that's one of the pulse width modulation output pins. I've got where I'm reading the signal, and then I have the ground clip on the ground pin over there. And then here you can see what the microcontroller is really doing. And this is really handy because it gives you a good visualization over time of what that pulse width modulation signal is doing. And this is really cool. So an oscilloscope is a handy tool for diagnosing things like this, or really just understanding things like this. So one thing I do like about this is that it has a USB-C connection right here, and this is to charge the battery, and also if you have a Windows computer, you can update the firmware. I am on a Mac, so I cannot update the firmware, but the instructions for doing that can be downloaded from the manufacturer's website. And I've found that the battery lasts a long time, but what I do not like is that I can't find any battery meter. I don't have any idea what the status of the current battery is. All I know is that it's working, and then I just occasionally charge it. Now, I believe that this screen, I believe a short press, nope, that's not it. Maybe it's a long press. Yes, long press. So a long press on the run, let's put our reference signal back up. A long press on the run will show or hide the information up on top, the Vmax, min, average, the VPP, etc. And so if you want to just look and you know your scale and you want to just count up on the bars, then you can do it that way, or a long press, you can see all the data. To turn it off, one quick click on the off button, and to turn it on, I believe it's a long press. It's pretty simple, but it does work, and I'm going to show you a couple of examples in the field that I've already done. Now here I'm testing an inverter, and as you can see I've got a pure sine wave, and that's one of the reasons why I bought this scope, because I wanted to make sure that the output of the inverter was as they advertised, and it is. And so that's pretty cool. I want to give you a quick tip on how to handle a display issue like this with this oscilloscope. So it can't seem to display anything and make any sense of the true waveform. So here's how to fix it. So what I'm going to do is disconnect the lead here, and then press and hold the calibrate button, this button, to calibrate it, and then press run and let it calibrate. Alright, now let's hook this back up. I've set this back up to my source. Let's try the, well, we could try and cycle through and see if we could maybe manually try and figure this out. Okay, we got it manually. All right, so that is a bit frustrating. So if this happens to you and it just goes bananas, then the rule of thumb is disconnect it and then recalibrate the oscilloscope. So I was able to get this manually. As you can see, we're at about 50. Well, it's kind of, the frequency is, it's supposed to be 60, but you can see that it's going as low as 54. And then this is an inverter. This is a pure sine wave inverter. And so the signal is not perfect, but at least I was able to correct this crazy mode that it was in. So in conclusion, This little pocket oscilloscope sort of does what it does. In other words, it's not very expensive, it doesn't have every feature in the world, but it does work. And I've been using it for the past couple of weeks, and I can get by for basic measurements. And so if you want all the features of a benchtop scope, well, then this isn't it. But if you want to get started and at least be able to do some measurements on sort of a simple scale, then this is probably a pretty good feature. My biggest gripe is the mini BNC connection up here. I really don't like that at all. But we'll see how long that lasts, and then I'll post any updates as to its longevity as time goes by. So that's it for today, and if you're interested in this, I'll put a link in the description and you can go check that out.